These are the notes for 5B, and now we're going to look at things about a statistical study that could make it biased or unbelievable. So there are certain things you're going to look at. A lot of this, again, like 5A, there's going to be a lot of notes and definitions, so make sure you have them in your notebook so you can refer to them quickly when you do your homework. All right, when you're evaluating a statistical study, most statistical research is carried out with integrity and care. Nevertheless, statistical research is sufficiently complex that bias can arise in many different ways. There are 8 guidelines that can help you answer the question, should I believe a statistical study? The first guideline is get a big picture view of the study. Try to answer the following questions. What is the goal of the study? Was the study an observation or an experiment? If it was an experiment, was it single or double blind? And were the treatment and control groups properly randomized? Given the goal, was the type of the study appropriate? So when you're looking at things, make sure that it's random in it and everything is done properly. And remember, in an experiment, there's only supposed to have one thing that's different on them. Everything else, the control group and the study group, have to have everything exactly the same. What was the population of their study? Was the population clearly and appropriately defined? So did they actually take a good sample of the total population? Number 2, consider the source. Statistical studies are supposed to be subjective, but the people who carry them out and fund them may be biased. For example, if you are a textbook producer, you might look at some statistics about how heavy textbooks are and lean more towards the heavier weight in a backpack that kids can carry because that would include your book. If you were a child doctor or a pediatrician, you might look at that and say that it's too heavy and it will hurt the kid's back, and you would use the statistics to argue that they shouldn't have to carry the textbooks. Guideline 3, look for the bias in the sample. Selection bias occurs whenever researchers select their sample in a way that tends to make it unrepresentative of the population. Participation bias occurs primarily when surveys and polls. It arises whenever people choose whether they participate. Because people who feel strongly about an issue are more likely to participate, their opinions may not represent the larger population. This one, you send out something, I know there's things in the mail that you can fill out surveys and stuff. That would be participation bias, because people are going to choose not to do that unless they feel strongly one way or the other, and then they'll participate. And sometimes participation only is if they get a benefit, a free gift card or free food or something like that. They get paid for it. Guideline 4 is look for problems in defining or measuring the variables of interest. A variable is any item or quantity that can vary or take on different values. The variables of interest in a statistical study are the items or quantities that the study seeks to measure. Remember, this is what your goal is in your study. They're the variables of interest. Let's do an example. Illegal drug supply. A commonly quoted statistic is that law enforcement authorities succeed in stopping only about 10% to 20% of illegal drugs entering the United States. Should you believe this? Well, your solution for this one is there are essentially 2 variables in the study: the quantity of illegal drugs intercepted and the quantity of illegal drugs not intercepted. It should be relatively easy to measure the quantity of legal drugs in the law enforcement officers intercept. However, because the drugs are illegal, it's unlikely that anyone is reporting the quantity of drugs that are not intercepted. How then can anyone know if the intercepted drugs are 10 or 20% of the total? In the New York Times analysis, a police officer was quoted as saying that his colleagues referred to this type of statistics as PFA, or pulled from the air. Guideline 5. Beware of confounding variables. Variables that are not intended to be part of the study can sometimes make it difficult to interpret the results properly. Such variables are often called confounding variables because they confound or confuse a study's results. Consider the setting and wording in surveys. Even when a survey is conducted with proper sampling and with clearly defined terms and questions, it is important to watch out for problems in the setting or wording that might produce inaccurate or dishonest responses. An example of this is, do you want a tax cut? A Republican National Committee commissioned a poll to find out whether Americans supported their proposed net tax cuts. Asked, do you favor a tax cut? A large majority answered yes. Should we conclude that Americans supported the proposal? The solution to this one is, a question like do you favor a tax cut is biased because it does not give other options, much like the fallacy of limited choice discussions in Unit 1A, which we did not cover, by the way. We skipped on and started at Unit 2. In fact, other polls conducted at the same time show a similarly large majority expressing great concern about federal deficits. Indeed, support for the tax cuts are far lower than the question was asked by independent organizations in the form of, would you favor a tax cut even if it increased the federal deficit? So if you're not given a choice in your question and they're just trying to bias it one way, then you might want to look at that. Guideline 7. Check that results are presented fairly. The study may be misrepresented in graphs and concluding statements. Researchers may misinterpret the results or jump to conclusions not supported by the results. For example, the school board in Boulder, Colorado created a hubbub when it announced that 28% of Boulder school children were reading below grade level, and hence concluded that methods of teaching reading needed to be changed. The announcement was based on reading tests on which 28% of Boulder school children scored below the national average for their grade. Do these data support the board's conclusion? The fact that 28% of the Boulder children scored below the national average for their grade implies that 72% scored at or above the national average. Therefore, the school board's ominous statement about students reading below grade level makes sense only if grade level means the national average score for a particular grade. This interpretation of grade level is curious because it means that half the students in the nation are always below grade level, no matter how high the scores. The conclusion that teaching methods need to be changed was not justified by this data. So they're taking it and they're completely jumping to conclusions with it. Guideline 8. Stand back and consider the conclusions. Ask yourself the following questions. Did the study achieve its goal? Do the conclusions make sense? Can you rule out alternative explanations for the results? If the conclusions do make sense, do they have any practical significance? For an example, an experiment is conducted in which the weight loss of people who tried a new fast diet supplement are compared to the weight loss of a control group of people who try to lose weight in other ways. After 8 weeks, the results show that the treatment group lost an average of ½ pound more than the control group. Assuming that it has no dangerous side effects, does this study suggest that the fast diet supplement is a good treatment for people wanting to lose weight? Compared to the average person's body weight, the difference of ½ pound hardly matters at all. So even if the study is flawless, the results don't seem to have much practical significance. It's not a large amount that they lose more than all the other ones. It's very insignificant, so it doesn't seem to have much practical significance.